In this video, we're going to look at a different pattern of reactivity, and this pattern is going to be for what we call combustion reactions. So combustion reactions are usually fast. They're rapid reactions that produce a flame. So for example, we have our Bunsen burner here. So methane gas is commonly used and then ignited. So that's what we see in this image here. So when we have in this balanced reaction, we have our methane gas here. We have a certain amount of oxygen needed. So we need 1 mole of methane, 2 moles of oxygen. And then on our product side, we're going to produce a 1 to 2 molar ratio of CO2 and H2O. So these are some of the indications here that we have a combustion reaction. First, we have a hydrocarbon, like we see here, just carbons and hydrogens. Next, our other reactant is oxygen gas. So we need oxygen to perform combustion, right? Something will burn in air, and what is really burning in is oxygen in the air. And then our products will always be carbon dioxide. So we have carbon dioxide in various amounts, depending on what our starting material is. If there's a 3 carbon compound, we expect to see 3 CO2. But with methane, we only saw 1 CO2 in our balanced reaction because there's only 1 carbon that we started with. So we get carbon dioxide and water. And you can remember this type of reaction because we do a similar like internal combustion reaction when we break down sugars, and those are hydrocarbons, so CH and O, and we breathe out CO2, and then we excrete water in other ways. So just remember that carbon or hydrocarbons and carbohydrates. So they would have just a CXHYO kind of generalized formula here, where whatever that hydrocarbon is, X, Y, and Z could be different subscripts. So let's see what happens when we burn a different hydrocarbon here mentioned in air, or not a hydrocarbon, a carbohydrate. So we have ethanol here, which is more commonly referred to as an alcohol. So we have C2H5OH. So we know that that's going to be one of our reactants. It's liquid form, and then we're going to burn it in air. So we know that we need some amount of O2 gas here. And then we're going to produce water and CO2. So CO2 gas and H2O gas as well. All right, so we need to balance this reaction. So we're going to write the same form, CH and then O, as we did in a previous combustion reaction example. And then we list our starting amount. So I have 2 carbons, 6 hydrogens, count both sets of hydrogen there. And then we have 3 oxygen to start over here. Oh, actually, I don't have just 3. I have, oh, yeah, I do. Sorry. We didn't do anything yet. So we still have just the 1 from the ethanol and the 2 from our O2. So those are my starting amounts. Let's look over here. I have 1. We know we should have 2 and then 3 oxygens. So that tells us again what order we do carbon first. So if that's balanced, we leave it alone. But since it's not, we're going to put a 2 out in front here. We're going to change that to a 2 on this side over here to account for those carbons. And now I've added 4 plus 1. Now I'm up to 5 oxygens over here. All right, so let's keep moving now that our hydrogen needs to be balanced. Second, I have 6 over there, so I need 3 times as many over here. That gives me my 6, but then I've added a couple more oxygens as well. So now I'm up to 7. So I have a 2 coefficient in front of my carbon dioxide gas, a 3 in front of water, and I'm almost balanced. Now I need to go back and look at my oxygens. I see 3 over here, 7 over there. So what do I do? Well, if I put 3 out in front of here, that will give me 6 plus one more gives me that 7. So I end up with a 1 coefficient here in front of the ethanol, a 3 in front of my oxygen, a 2 in front of CO2, and then a 3 in front of water. So we have a 1 to 3 to 2 to 3 ratio of our reactants and products when we balance this combustion of ethanol.